Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hello, everybody. Welcome to a brand new episode of the Clear to Send podcast. I am your host, Roel Dionisio. This week, I will be doing this episode on my own. Francois is unable to record with me today, but in this episode, I wanted to talk about something that's been on my mind as I've been troubleshooting some networks here in the Bay Area, and that's going to be on the topic of 802.11w. But before we get to that, one piece of news that Francois shared with me through Slack was this new flagship phone that's coming out by Samsung this year, 2019. And apparently, it's going to be supporting 802.11ax, or as some of you guys know, which is now rebranded as Wi-Fi 6. And so that's going to be interesting because of the Wi-Fi 6 capable access points that will be available. We already have some available to purchase through Aerohive, and I'm assuming a lot more will come out. We'll probably hear some announcements also later this year, or maybe earlier this year, from other vendors, but it is not a standard yet, and it is still in draft mode, so it could be up in the air about how this will be. But you know, it'll be really interesting to see these Samsung phones come out with AX support, because there are going to be a lot of consumer APs available with AX support, and I'd like to get my hands on some of these products to test out performance and how they operate currently before they are a standard, and then in comparison to seeing how it is supported once 802.11ax is a standard and it's ratified. So we look forward to seeing that coming out from Samsung. They're going to tout all the battery power that is saved, the faster speeds that a lot of these vendors are claiming, and we'll finally see what that looks like. So that's the one bit of news I have for you today. And this past week, I've actually been traveling. I made it out to the East Coast, and during my flight, I was thinking about some of the troubleshooting that I've done in the Bay Area. And as my laptop just draws a blank, as I try to pull up my notes here, one of the things that I notice in the Bay Area, and I assume that you've probably seen this as well in your environments, is the deauthentication attacks that come from neighboring wireless networks. And so one of the solutions to this, to protect your own network, could be 802.11w. And 802.11w really just applies robust management frames that are actually, what I want to say is it protects those management frames with protected management frame, which is PMF in short. And so in wireless environments that could be plagued with a lot of rogues, your wireless environment could be susceptible to eavesdropping, and that's because data is already usually encrypted. You know, if you're using pre-shared key or 802.1x, any type of encryption, that data traffic, the data payload within those frames is already encrypted. And the management frames are usually unencrypted. And so the goal of 802.11w is to protect those management frames from things like forgery or spoofing from APs that are not part of your environment. And so one of the things in San Francisco, for example, you got a lot of high rises, a lot of neighboring wireless networks. There are different wireless systems that have features that are described as security features, where you could actually contain rogue APs, right? You can protect your wireless network from rogues, from any APs that should not be connected to your wireless network. And so that's how that feature is supposed to be used. You know, your WIPs, your wireless intrusion prevention systems, right? And so when, and I feel that when some of these administrators who may not be wireless experts or networking experts in general see this feature, and then they notice, oh my gosh, I see hundreds of rogues that appear to be attacking my wireless network. Maybe if I do something about these rogues, I can make my own wireless network faster or prevent those wireless networks from quote unquote interfering with my own enterprise wireless network. And so a lot of those people tend to enable a feature where it should not be enabled, such as containment. And containment, different words can be used to describe this feature, but containment is usually the best word I find to describe how neighboring wireless networks try to prevent others from interfering with their own. And so one of the things I see a lot is some of the clients I run into, their users cannot join a wireless network. That is usually one of the first indicators. They see their SSID, they either automatically join, but then they get disconnected immediately, or somebody has already been joined to the wireless network, but then they get kicked off, and then sometimes they cannot reconnect, or they have to manually reconnect to that wireless network. But in doing so, they tend to get disconnected somehow, right? And that is the story that I see in the city, in San Francisco, because a lot of these people are enabling this containment feature, and one of them, if you're in Meraki, is Air Marshal. And so I have seen other organizations use Air Marshal to contain neighboring networks because they see the list, they see these SSIDs that are very strong, they're on the same channels, and then they select that as being part of their containment list. And I've seen that also in Cisco networks as well. And the way that I look at this is when I'm troubleshooting these networks and these troubles that these guys are having connecting, is I'll do a frame capture. So I'll do a frame capture on the same channels that they are using on their internal network. And then you can filter on all those frames that you collect and just filter it on the authentication frames. And I believe that's the subtype 12 that you could plug in there. We do have a filter list or a filter sheet that you could use, a cheat sheet for Wireshark. I'll link out to that in the show notes. If you go to cleartosend.net/158, I'll have a link out there to that cheat sheet. And also, if you head over to the show notes, I'll show you some of the examples that I did in my lab to try to so you can look at protected management frame, and also some example screenshots from Wi-Fi Explorer showing how to detect whether or not PMF is enabled or not enabled. And so going back to the story of troubleshooting these networks, once I capture these wireless frames and I do see deauthentication attacks, and usually it's going to be spoofed as one of your own APs, and it's sending out a deauthentication to a broadcast address on that channel. And so usually you'll see it and you go, well, that's my BSS ID that's telling everyone to get off the wireless network. But usually that's because it's another AP that is spoofing your BSS ID and telling everyone to get off. And so one of the ways that I've troubleshot this is capturing those frames, and then looking at one of the columns there in Wireshark, you can see your beacon frames and the signal strength, right? But when you look at the BSS ID of that beacon frame, and for example, you see it at neg 60, right? And then if you filter on the deauthentication frames from that same BSS ID, but you also see that maybe at a neg 80, for example, or neg 70, it's a different signal strength. So usually that's one of the indicators that I see of, okay, someone is spoofing your BSS ID and they are telling everyone to get off the wireless network. And so what you could do is try to capture those frames and get closer to that signal. And then you could use a network scanner, a wireless scanner, such as Wi-Fi Explorer, to see who is broadcasting on that channel around that same signal strength. And so I tend to look at who is the offender there. Same signal strength as the deauthentication attacks, and that could be a pointer at who is doing the deauths here. Or one of the ways to see who's also doing deauth attacks, sometimes it's not a spoofed BSSID. Sometimes that deauthentication attack comes from a BSSID that is also broadcasting their own wireless network. So what you could do is when you're doing a frame capture, you see a lot of deauthentication frames and they're going to a broadcast address, for example. And then you could take that BSSID and do a search for that BSSID within your wireless network scanner and see which SSIDs show up with that BSSID. Hopefully it's a good indicator of the business name described on that SSID, and you can go talk to them and ask them if they can stop doing containment. And you may want to talk with some legal experts about that, because they shouldn't be doing any deauthentication attacks or any sort of containment on other wireless networks. And when you are using something like a Cisco wireless network system and you try to do a containment, it does tell you that there could be some legal ramifications there if you enable that. It may not be legal in your regulatory domain to do this. And so that's something to consider. Do not take it lightly. If you see that message, you should really find out if you are allowed to do something like this, right? In the US, you shouldn't be doing that. It does no good for anybody. And so as I try to loop this back into 802.11w, sometimes it may not be possible to get to the root cause, right? The person who is doing these deauthentication attacks. And so when I started looking at 802.11w as one of the solutions here, 802.11 again, 802.11w again is a way to protect management frames from forgery or spoofing. So when we look at the deauthentication attacks, this example that I've given, it's a way to prevent some of those denial of service attacks, because it is denying users from getting onto their wireless networks. And it's going to use some sort of cryptographic encapsulation mechanism for those robust management frames, as it's defined under RSNA in the 802.11 standard. And so what are those robust management frames? I'm talking about your disassociation frames, your deauthentication frames, and a specific number of action frames. And so when we look at specifically disassociation, let's start there. The disassociation frame it can be initiated by either a station or an AP. And when this disassociation frame is transmitted, it is not a request. It is a notification. It is, I am disassociating, or you are disassociated from the BSS. That's an example, right? And it's not something that can be refused by the AP, or it's not anything that can be refused by the station, except when management frame protection is enabled and negotiated. And if management frame protection is enabled, there is this integrity check. And so if the integrity check fails, then the station or AP will just discard that frame. And so when we look at the deauthentication frame, that is equally about the same. It is not a request. It is more of a notification. It is a deauthentication. And so when it comes from the AP, it is a notification to either a unicast to a specific client or station, or it is a broadcast to everyone on that channel, which is you are deauthenticated from the BSS. And likewise with the client will send a deauthentication to the AP, and it is just a notification. The AP, it is not a request to the AP. The client is saying, I am deauthenticating from the BSS here. And so these, again, this the authentication and disassociation cannot be refused. And so here we have this problem then when you do not have 802.11w enabled, where if I am spoofing another MAC address or BSSID, I am able to deauthenticate someone. And these types of attacks are ways that someone in the middle, someone malicious, can get you to join a rogue AP. That's an example, right? So you can use something like those Hack5 devices that where you can be a rogue AP and you deauthenticate a device from its real AP to make it join your AP. And then now you act as this man in the middle and you do this man in the middle attack. And so this is where I think 802.11w will come in handy. And so really what this implements is something called data origin authenticity, right? You want to define a way that a frame being received at a station that it knows that it's being transmitted by like an AP that you trust or from a device that you trust. And so usually this is mainly done through data frames, but you can also do this through the robust management frames. And so when we talk about the frame format of something like 802.11w, when you're looking at the frame, when you're capturing frames, you can see this in the beacon frame. Within there is a protected frame field, and if that is enabled, it will be set to 1. So a network that is it'll be broadcasting management frame protection capable or management frame protection required. Usually those are set to no, 0, they're off. But when 802.11 is enabled, that'll be set to 1, or in the case if you're looking at through a network with Wi-Fi Explorer, it'll set to yes. And so I'll include some screenshots of this with my own lab SSID. You can see where that frame is within the RSN information element. And the AP will be broadcasting this MFPC for management frame protection capable or management frame protection required. Those are the two that you'll see there. And so when it negotiates the 802.11w, this happens after the authentication, the association, and if you have 802.1x, it happens after 802.1x authentication and also after key establishment, because keys are going to be used as a way to authenticate, yes, this frame, this management frame is from a trusted station or access point. And the same is applied to group addressing, which will be will have this data integrity through broadcasts or multicast integrity protocol, or BIP, and it's going to protect group management or group addressing those frames to a group as it'll protect the data integrity and the replay, also the replay protection of those management frames addressed to a group. And so when we look at how this is implemented as well, this is also addressed in the RSN information element. Within there is a group management cipher suite. If you expand that within Wireshark, you'll see a group management cipher suite type, and that'll be set to BIP. So how does this look as it's implemented? In my lab environment, I have two different wireless network systems. I have an AP from Fortinet, and then I also have an AP attached to a controller from Cisco. So I'm using a 3800 to a 2504 wireless LAN controller. And so with the Fortinet AP, I'm broadcasting an SSID, and I just named it Clear to Send. And so what I'll do is I'll add some of the screenshots, and I'll try to share some of the frame captures that I have that I used for this episode here. And so without management frame protection required, like I said before, it's going to be susceptible to a denial of service attack. And so initially we don't have that enabled. It's usually something you have to set, and it's not enabled by default. And within the RSN information element, again, the MFPR and MFPC, the capable, it will be set to no. And so I'll include a screenshot for that. And then with my other wireless system, the one that's being that's used with Cisco wireless LAN controller, I enable containment on the clear to send SSID and the channel. So in this case, I'm using channel 165. And I see the SSID within the rogues section of the controller. And I go into that BSSID and I say contain this BSSID with 1 AP. And so when I do the frame capture, before doing the containment, I don't see any deauthentication frames. But when I do enable containment and then do the capture on channel 165, I start seeing a lot of deauthentication frames coming from the BSSID broadcasting the clear to send SSID, which again is being broadcasted by the Fortinet AP. But clearly I can see that these are two different signal strengths because I am sitting closer to my Fortinet AP, which is in my living room. And in my garage, which is below me, one floor below, I have my 3800, which is doing deauthentication. It's spoofing the BSSID and it's sending those deauthentication frames. And I see those coming in at a different signal strength. And so noticeably, I was able to see my devices unable to connect to the clear to send SSID. My phone, I could see the beacon. I could see the SSID listed. And when I tap it on my phone, it tries to connect, but then it just never fully associates with that BSSID. And so every time I tried that, it would just it would fail. And with my laptop, I was able to notice that it would just drop off the SSID, but then try to join again. And so unfortunately, I didn't save those events using Wi-Fi Signal. There is an app on the Mac called Wi-Fi Signal, and you could see the events, the joins and the disconnects. And I was able to see that with my laptop. So then with the Fortinet AP, I was then able to enable protected management frame on the clear to send SSID. And so with it enabled, I do have a screenshot for this, which is in the show notes. The RSN information element is changed to management frame protection required and management frame protection capable of yes. And I was able to do this with the Fortinet AP through command line. You edit the wireless controller VAP, edit the VAP name, which is associated to the SSID, and then you just do a set PMF enable. And then you end it to save the configuration. And so with containment still enabled on my Cisco AP, which is containing the clear to send SSID, which is being broadcasted by the Fortinet AP, I was able to successfully join my clear to send wireless network without being disconnected by those deauthentication frames. And the reason for that is because that deauthentication frame coming from Cisco, the Cisco AP, fails to be authenticated by the client and the AP as a frame that is able to be accepted. And so when the client sees that frame and the keys there fail, the client will just discard the frame. And also when the AP hears that, it just discards the frame. And so that was a way for me to mitigate those deauthentication attacks, which I thought was pretty cool. And so when looking at this, you want to make sure that for one, clients can support 802.11w. And that is going to be the number one thing to look out for. Second, you want to test it. You want to make sure that you don't have things like performance hits when you've got this enabled. And then the other thing to consider too is that PMF is going to be required in WPA3 and also I believe in OWE, if I can recall those off the top of my head. So we will be seeing more of this in the future. This is going to be coming down the pipeline and ensuring that we secure our wireless networks. This feature is available probably in almost all of the enterprise grade equipment. You can enable this if you want to and implement it. 802.11w has been around for a long time. I want to say since 2009, I believe. And so it's worth playing with it if you're seeing a lot of disconnects on your network, you're seeing a lot of deauthentication attacks. And some of the wireless systems can identify that. If you've got a decent security module within your wireless network, you should be able to catch those attacks to your devices. And so that's something to consider, something I've been thinking about, and a solution that I've been trying to push to people for those that are surrounded by a lot of wireless networks in the city. And again, if you head over to the show notes, cleartosend.net/158, I will have some screenshots and some sample management or sample frame captures that you could look at in order to see how this works. So there you have it. That's our episode for this week. If you have any questions, hit me up on Twitter @cleartosend or leave a comment in the show notes. Let me know if you are using 802.11w, if you have it enabled and it's working for you, or you've tried it and something wasn't working quite right, or if there's anything that I'm missing in this episode, let me know in the show notes, cleartosend.net/158. And if you haven't already, head over to cleartosend.net/iTunes, leave us a review, let us know how we're doing and how our episodes are. If they're relevant to you, or if they aren't, let us know how we're doing. We appreciate that, and it also helps others find the podcast as well, and let them know, and that lets them know how the show can help them. And so, if you found this episode useful, go ahead and share it out with your colleagues, your friends, and anyone else who might find it useful for their environment. So there you have it. That's our episode today, 802.11w, and we'll see you on the next episode.